Hello Wisdomers and welcome back to another video of our C programming course. In this video, we will try to understand another group of operators in C, which is bitwise operators. So what is the use of these bitwise operators? So the name itself is stating that we can do operations on the bits of the values. So let's see the use of these bitwise operators. Bitwise operators allow a programmer to directly work with individual bits. So in your program, the values, whatever the values that we have, if you want to work on the individual bits of those values, so then the bitwise operators are very much helpful. So there are 6 different types of bitwise operators. So the operators are AND, Bitwise OR, Bitwise Exclusive OR, Bitwise NOT, Bitwise right shift operator and Bitwise left shift operators. So in this class, we will try to understand the basic group of operators. So first 4 operators, the right shift operator and the left shift operator we'll try to understand in our next class, because these operators are a bit complex to understand. So we have divided it into another part, another video. So there we are going to discuss about these 2 operators. Now starting with bitwise AND. What does that mean? So we have already seen this AND, but it is logical AND operator. So the logical AND operator, the same operation is applied, but it is done on individual bits. So in the logical AND operator, what we have done, so we are going to take some relational operators and an expression, so which consists of relational operations. If you get, so the output of those relational operators will be applied. So the outcomes will be applied on the logical operators. So we have seen several examples also on these concepts. But what about bitwise AND? Bitwise AND is going to be a bit different. So for example, so we'll try to understand this concept by using an example. So I have taken 2 decimal values, 12 and 5. So on these decimal values, we are going to apply this bitwise AND. So what are the binary equivalent of this 12? So this first value is the binary equivalent of 12 and this one is binary equivalent of 5. Now if you apply bitwise AND on this operation, on these 2 values, what is that we are going to get? So what are the rules? What is the truth table of AND describes, logical AND describes? It is whenever both the values, whenever all the values are 1 or true, then only it is going to produce an outcome of true, means 1. So if any one of the value is 0 or false, it is going to produce an outcome of 0. Okay. So now what we will do, this is the binary value of 12 and binary value of 5. On this we are going to apply bit by bit. That is the reason why it is called as bitwise. So on every bit of the values, we are going to apply an operation. What operation we are applying here? It is AND operation. So means 0, 1. Are these 2 values or ones or true? No. One of them is false. So it is going to produce an outcome of 0. And what about this 0, 0? This is also going to produce an outcome of 0. And 1, 1. So here is the point where an AND operator is going to produce an outcome of 1. Okay. And what about this? This is 0 and remaining all are zeros. So this is how the bitwise operators, this is how we are going to apply bitwise operators. So is there any need of doing such kind of operations in real world? Yes. There are multiple uses where we are going to use these bitwise operators. So we are going to cover all these usages while we are doing our programming assignments. As of now, so this is how the bitwise operators will work. Try to understand that. Okay. Now the next one is bitwise OR. So the bitwise OR is, so the same operation OR operator, OR operation is done and we have taken the same values, it is 12 and this one is 5. Okay. So now if you apply bitwise OR, what is the truth table? The truth table I have written here. So if any one of the bit is 1, at least one bit should be true so that the outcome is going to be true. At least one. So here one bit is true, so we are going to produce an output of true. Here this bit is true, so we are going to produce an outcome of 1, and both the bits of at least 1 should be true. Okay. means if both the bits are true is also accepted. Okay, that is what we call it as OR operator. We have seen these examples, right? So this is going to produce an outcome of 1. Now we will apply this logical operation of OR on the bits of these 12 and 5. Let's say this. So 0, 1, this one is going to produce an outcome of 1 because at least 1 should be 1. 1 should be true. And 0, 0, this one is going to be 0. 1, 1, this one is also a 1. 1, 0, this one is also 1. And all these are 0, 0. So this one, all these 4 zeros are going to produce an outcome of 0. So that is the use of bitwise OR operator. And the next one is bitwise XOR. So far in any of the concepts we haven't covered this XOR operation. This XOR operation, the name XOR stands for, this X means it is exclusive OR. So what is this exclusive OR means is, so at only one bit should be true. Then only we are going to produce an outcome of 1. If both the bits are 0 or both the bits are 1, then it is going to produce an outcome of 0. So come back, let's discuss this again. So because these are, this look like very similar to the OR, but it is exclusivity, and exclusivity is added to this logic. So what is that exclusivity is, only one bit should be produced, should possess a value of 1. Then only we are going to produce an outcome of 1. Okay. So now see this, the truth table of XOR. So if both the bits are 0, then it is going to produce. If both the bits are, the logical understanding of this exclusive OR, so that logical understanding is very important. So what is the logic that we are going to get from this exclusive OR? So that is very important. So the logic that we are going to get from this exclusive OR is, if both the bits are same, produce an outcome of 0. If both the bits are different, means one is 0 and other one is 1. In that case only we are going to get an outcome of 1. So if two bits are different, produce an outcome of 1. If both the bits are same, produce an outcome of 0. So this is logically very strong point. Okay. So now, so 0, 0, both of them are same. So it is going to produce an outcome of 0. 0, 1, they are different. So 1. 1, 0, again they are different. Both the bits are different. So it is going to produce an outcome of 1. 1, 1, it is going to produce an outcome of 0 because both of them are same. So that is what we call it as exclusivity, exclusive OR. So this is how bitwise exclusive operation, exclusive OR operation is done. So let's apply that logic on these two numbers, which is 12 and 5. What we are going to get, 0, 1. So both are different. We are going to get an outcome of 1. 0, 0. This one is going to produce an outcome of 0. 1, 1. Both are same. So this one is going to produce an outcome of 0. 1, 0. This is different. So 1. And remaining 4 bits are zeros. So we are going to get an outcome of all zeros. So this is the outcome for exclusive OR. And what about bitwise NOT? Bitwise NOT. Bitwise NOT means just complement each and every bit. Just complement each and every bit in the given number. Okay. So let's, I have taken this 5. So this is the binary equivalent of this is, the decimal equivalent of this binary number is 5. And what we have to do, if we apply bitwise NOT, we have to just flip the bits. If it is 1, make it 0. If it is 0, make it 1. So this one is 0, 1, 0. All these bits are 1s. Okay. Now, are you going to remember something from this? So this is what we call it as what we have learned in the 2's complement. In the 2's complement, first we have to do 1's complement. In the 1's complement, we have to flip the bits. So how we are going to get that flipping? That flipping can be obtained by using this NOT operator. Try to understand this. If you use this NOT operator, all the bits will get flipped. The outcome is, this is the outcome for this 5. Okay. So that is the use of bitwise NOT. And what about left shift and right shift operators in bitwise operations? So bitwise operators are having another 2 bitwise operators, which is left shift and right shift. So that we will try to understand in our next class. So that's it for this video. Hope you got the point on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this concept, please post your doubt in the comment section below. If you feel that this video is helpful to you, please give us a like and please share this video with your friends so that everybody will get helpful. Thanks for watching.